Hello and welcome back. In this session, we're going to look at how to maximize or minimize a given function over some region. Here we have an f of x, and x is defined for all points in the closed interval a to b. This function that's usually given that we want to maximize or minimize, it's called the cost function. Usually we are required to find the maximum or minimum value of this cost function over some interval for x. In this case, x lies between a and b, subject to some conditions. And those conditions are called constraints. And those constraints are given in the form of an equation. Here there is this equation, g of x equal to k. And our goal is to maximize or minimize this function. Here we have an example where we are asked to maximize or minimize the product of two numbers whose sum is equal to 20. Let's first identify the cost function and the constraint function for this question. Let's say we have the two numbers, we call them x and y, and whose product is our cost function. In other words, product of x and y denoted by x times y is the cost function that we want to either maximize or minimize. In this case, our constraint given is that the sum of these two numbers is 20. That means constraint function becomes x plus y is equal to 20. So our goal in this question is to maximize as well as minimize this cost function. It's a function of x and y subject to the constraint. When I say it's a function of x and y, I mean it depends on both what x and y values are. So that's what we're going to look at. In these kind of questions, what we usually do is we use the constraint function to reduce our cost function. What do I mean by that? We use the constraint function to express our cost function in terms of one variable. Since x plus y is equal to 20, so we can write y equals 20 minus x. Now, we are going to express our cost function, which depends on x and y. We're going to write it purely as a function of x. And since it's equal to x times y, where y is equal to 20 minus x, so we can write this cost function p of xy purely as a function of x. Let me call it p1 so we can see the difference. P is a function of two variables, and I expressed it as a function of one variable, and I called it p1. This is just a notation, just to make sure that we don't confuse the two terms. So our goal is to maximize and minimize this p1 function, and we know from our knowledge about derivatives that a maximum or a minimum occurs when we have the derivative equal to 0. So our derivative for this cost function becomes 20 minus 2x, and we want to set that equal to 0 and solve it, which tells me 2x is equal to 20, therefore x is equal to 10. So this x equal to 10 is a point at which either the maximum or the minimum will occur. The second derivative of this cost function is equal to -2, which tells me that the function must be the x equal to 10 value must be the maximum value for that function. Since x is 10 and our constraint is x plus y equal to 20, which gives me y equal to 10, so this shows me that x equal to 10 and y equal to 10 corresponds to the maximum value of the cost function. As you can see, when x is 10 and y is 10, product is simply 10 times 10, which is 100, and the constraint x plus y equal to 20 is also met. So this is our maximum product. To see if this makes any sense, let's take our cost function P of x is 20x minus x squared, and write it in the standard quadratic form, a times x minus h squared plus k, where a, h, and k are numbers which we're going to find out from this expression. So we're going to complete the square here. I took this negative common, negative, and then x squared minus 20x, and we add 100 and subtract 100 to make this into a proper quadratic form given here, ax minus h squared plus k. Therefore, this expression can be written as negative x minus 10 squared plus 100. Now, if you solve this expression, and that will tell us x is equal to either 20 or x is equal to 0. So x equal to 20 and x equal to 0 are the two x-intercepts of this quadratic equation here. Now let's graph this quadratic expression, negative x minus 10 squared plus 100. Since we know x equal to 0 and x equal to 20 are the two x-intercepts, so the quadratic curve will go through them. And this negative sign here in front of this expression tells me it's a curve down, concave downwards. And between 0 and 20 is this, in the center is this line x equal to 10 line. And when x equal to 10, the value of this point here, when x is 10, it is equal to 100. So when x equal to 10, this vertical axis, y-axis, gives me the product. And the x-axis gives me different values of x. So if we choose x equal to 10, correspondingly we'll choose y also equal to 10, because x plus y has to be 20, the constraint that we have. And if x and y are both 10, the product is equal to 100. So as you can see, this corresponds to the maximum product. Now as you can see, there is no minimum value, because if we allow the x and y values to become negatives, then this curve will continue in this direction below the x-axis.